So the prime factorization problem is kind of interesting. The way it works is if you have a number like 18, what the algorithm should do is print out all of the prime numbers that are multiples, whose multiples add up to 18. So how would that work is you would take 18 and that's evenly divisible by 2, which is a prime number. So it would print out 2. And then that leaves us with 9. And then 2, which is like the lowest prime number aside from 1, is not evenly divisible into 9. So that's not a multiple. And then we would use the next prime number, which is 3. And 3 is evenly divisible into 9. So we would print out the 3. And then that would leave us with 3. And then we would take the 2, which is the lowest prime number, and try to evenly divide it into 3. That's not possible. So then we would try using the next prime number, which is 3, and evenly divide it into 3, which is true. So we would print out the 3, and that leaves us with 1. And we are done with our prime factorization. And you'll notice that if you multiply these 3 numbers together, you get 2 times 3, which is 6. 6 times 3 is 18. And that should be our answer. And so I probably messed up on the terminology there, but that's the general idea. And now the question is how do you get your computer to solve this issue, right? Because in our mind, when we go ahead and try to create the prime factorization of 18, we just kind of say, okay, what times what multiplied together equals 18. And then you break that down further, and you break those 2 down further into multiples until you finally end up with 2 times 3 times 3. So it's kind of different when we're making a computer do that. And so this problem is interesting because it uses the isPrime function that we coded a couple of lessons back. And the isPrime function, you give it a number and it will tell you if it is prime. Right? And that's going to be useful here because that way we don't need a list of prime numbers. We can feed numbers like a counting number, a variable, into isPrime to get the prime numbers that we're going to use to test to see if it evenly divides into the given number. Right? All right. So how do we do this? Well, we probably need a loop to get going. And since this number here, 18, is going to change over time depending on the input from the user, we need a while loop, right? Because we don't know how many iterations we need to run the algorithm. And so we could say while. And I guess the condition we want to say is, let's say this number here that they're going to enter in is an n, a variable called n. Then we could say while n is not equal to 1, right? Because this is where we want the looping to stop, right? 18 is not equal to 1, run the algorithm. 9 is not equal to 1, run the algorithm. 3 is not equal to 1, run the algorithm. 1 is not equal to 1, that's where we break, right? So that's why we're going to use the n is not equal to 1. And then for every iteration here, we want to find the lowest prime number that's evenly divisible into n. And so to find the lowest prime number that's evenly divisible into n, we need to have a loop, right? And so in this case, we're going to use a for loop. And so we'll say for I is equal to, we're going to start I at 2 because I is going to be the possible prime number. And then we'll say I is less than, let's just say some really big number. And in actuality, this for loop should be a while loop, but to make the algorithm a bit more simple, we're just going to use a for loop, and we can maybe put a really big number here. Okay. And of course I here is the possible prime numbers that we're going to use in our little algorithm. So we'll say I++. And then what are we going to do? So for every n, we're going to check the first prime number that's evenly divisible into n, right? So first of all, we need to check if I is a prime number. So we're going to say if is prime. This is taking us back to the previous to the previous problem that we solved earlier, right? And so this is going to take in a number and return true if I is prime. It's going to return false if I is not prime. And so this is going to be true if I is prime. And so, okay, great. Now I is prime. That's the lowest possible prime. It's going to be 2, then it's going to be 3, then it's going to be 5, and 7, right? So when I is equal to 4, this is going to return false, and this body is not going to execute, right? So once we get into this if statement, we know that I is a prime number. And so what we can do now is we could say if, and now we're going to check if it's evenly divisible. And so we're going to say if n mod I equals 0. That's only true if n, the number that we're using, let's say the 18, is evenly divisible by I, which is the prime number that we're using, which in this case, the first iteration of the for loop, I would be equal to 2. And so if that's true, then what do we want to do? Well, we want to, first of all, print out that prime number, print out the 2, and then modify n so that it is the result of n divided by 2. All right. So let's first start by printing. Print ln I, and then we are going to modify n's value. So we're going to say n is going to be equal to n divided by I. And I think that would solve everything. Yeah, I think that's it.